Hello and welcome to Martin Maths. We're going through a foundation GCSE paper. This question is on standard form. We've got 1.63 times 10 to the negative 3. We have to write it as an ordinary number. Remember, 10 to the minus 3 is the same as 1,000th. So I'm dividing by 1,000. So 1.63 divided by 1,000. So each decimal place, that would be divided by 10, dividing by 100. That would be 10, that would be 100. There would be 1,000. And as you can see, there's a 3 there, and I have 1, 2, 3 zeros as a rule of thumb. So 0.00163. And if I were to times it by 10, times it by 100, times it by 1,000, I'd get back to that 1.63. Okay, that should give us 1 mark. Then write 438,000 in standard form. Remember, I need a number that lies between 1 and 10. So I'm going to do 4.38, and I have to multiply it by some power of 10 to get back to there. That's 10 to the 1, 10 squared, 10 cubed, 10 to the 4, 10 to the 1 squared cubed, 4 to the 5. So 10 to the 5. Because if I times something by 10, it'll be tens, hundreds, thousands is 10 cubed, 10 thousands is 10 to the 4, and then 100,000s is 10 to the 5. Okay, so that would be the answer, 4.38 times 10 to the 5. And you can see it in the place value. And it's useful to know that 10 cubed is 1,000, 10 to the 6 is 1,000,000, and those should be your kind of benchmarks. 1,000 is 10 cubed, 1,000,000 is 10 to the 6. And this is less than 1,000,000, it's 10 to the 5. Okay, now we have to multiply 4 times 10 cubed by 6 times 10 to the minus 5 and leave it our answer in standard form. I'm going to do the units first. That's going to be 24. Then I'm going to use index laws to multiply those two together. So 24 times, add index laws, 10 to the 3 minus 5 is minus 2. It's not in standard form because 24 is 2.4 times 10. Okay, 10 to the 1. So 2.4 times 10 to the minus 1. Okay, so that's why it's a 2-mark question. 1 to do this calculation, and then 2 to make sure that it's in standard form. So we get 2.4 times 10 to the minus 1. I'm using index laws as well as standard form there. Okay, I've added the indices here, but then I need to remember there's a power of 10 in there that I take out, that 10 to the 1, and I do 1 minus 2. Okay, and just check that 24 to the, that would be 0.24, and that would be, 0.24. I get the same answer. Okay, let's move on to question 28, which is on graphs and substitution. Y equal to x squared minus 3x plus 1. So I need to fill out this table. I need to use substitution. Complete the table of values. They've done the table of values for us, because they've also chosen the easiest ones. The 0 and 1. 0 minus 0 plus 1 is 1. Minus 1 squared is 1 plus minus 3x times minus 1 plus 1. You get minus 1. It would be minus 1 squared minus 3 times 1 plus 1. So I get 1 minus 3, which is minus 2 plus 1. End up with a minus 1. Let's try it here. 2 squared minus 3 times 2 plus 1. Which is 4 minus 6 plus 1. That's minus 2 plus 1. You get minus 1. With 3, should see symmetry. 3 squared minus 3 times 3 plus 1. I'm going to get 9 minus 9 plus 1, which is 1. Now I'm starting to see the symmetry. So the line of symmetry will be there. 4 squared minus 3 times 4 plus 1. 16 minus 12 plus 1 should be 5. And that's what I should get here, because we should see it's a positive quadratic. So I should see that shape with a line of symmetry there. So let's try this. Minus 1 squared minus 3 times minus 1 plus 1 is 1 plus 3 plus 1, which is 5, which is exactly what I was hoping for. So you can see it reflects, there's, as I say, there's symmetry, and I should see the shape reflecting. Right, now we can plot these. For another 2 marks, we need to draw the graph. So we need to use this skill of plotting and understanding coordinates. Start with the ones that they've given us, because we know they're correct. 0 and 1. When x is 0, y is 1. When x is 1, y is minus 1. Okay, now we want to put in our points. 2 and minus 1. 3 and 1. 4 was 5 up there, and minus 1 was 5. And you can see we're probably right because it's fitting in the grid correctly. They haven't given us too small or too large a scale. Use a pencil to connect these freehand, better than I've done there. And you can see the line of symmetry somewhere around there. But now it says use your graph to find the estimates for the solutions. So that's where it cuts the axis of this equation. So roughly there and there. They could have asked us for the turning point, which would have been there, but that and that would be the solutions. So the x values would be around, say, 2.6 and maybe 0.5, somewhere around there. They usually give you some degree of freedom. Okay, so that's 2 for 6 marks on a nice graph question. Thanks for watching. Don't forget to like, subscribe, and share.